Question 9. This question is about reversible reactions. When 4.68 of hydrated copper sulfate changes into anhydrous copper sulfate, 2.99 grams of anhydrous copper sulfate is produced. 1.47 kilojoules of energy is taken in from the surroundings. The equation for the reversible reaction is hydrated copper sulfate in equilibrium with anhydrous copper sulfate plus water. Question 9.1. Calculate the maximum mass of water that can be produced from 11.7 grams of hydrated copper sulfate. This is a ratio question. So we know that the water from the hydrated copper sulfate, the mass is 4.68 grams and anhydrous is 2.99 grams. Anhydrous means no water. So that means this is the water here. So we know this one is 4.68. This is 2.99. The difference between these will give you water. So we can say the mass of water in 4.68 grams will be 4.68 grams minus 2.99, the mass of anhydrous, and that gives you 1.68 grams. The mass of water in 11.7 grams will be the ratio of these two times that one. And that would be 11.7 over 4.68 times 1.69, and that is 4.23 grams. Another way to do this question is to use mass of anhydrous compound, which is 11.79 over 4.68 times 2.99, because that's the mass of anhydrous copper sulfate, and that gives you 7.475 grams. And the difference between that 11.7 minus 7.475 will give you 4.23 grams. So the answer we're looking for is 4.23 grams. Question 9.2. 50 grams of anhydrous copper sulfate completely changes into hydrated copper sulfate when water is added. Calculate the amount of energy transferred to the surrounding. Well, in this case, we know that energy is going to be the 15 grams of anhydrous copper sulfate divided by the mass of the anhydrous of the 2.99 times the energy that was taken in from surrounding, 1.47, and that would be 7.37 kilojoules. And so the amount of energy transferred to the surroundings will be 7.37 kilojoules. The gases nitrogen dioxide and dinitrogen tetroxide reach dynamic equilibrium in a sealed container. The forward reaction is exothermic. So going that way, it's exothermic, which means it's minus delta H. 9.3. What happens to the position of equilibrium in this reaction if the temperature is increased? Because this is a negative enthalpy, if it's exothermic in that direction, it wants a low temperature. If you increase the temperature, the reaction will go backwards. It will shift to the left. If you decrease the temperature, the reaction will shift to the right because it's exothermic. It wants a low temperature, no high temperature. So the question is asking, if the temperature is increased, then the reaction will shift to the left. So we're looking for that. Reaction shift to the left. Question 9.4. A teacher seals a brown-colored mixture of nitrogen dioxide and dinitrogen tetroxide, which is colorless, and this is brown, in a gas syringe. The teacher pushes the syringe piston in. This increases the pressure in the gas syringe. What is the color of the mixture when a new equilibrium position is reached? The reaction is 2 nitrogen dioxide in equilibrium with N2O4. This is brown and that's colorless. And what you see is not going to be, you're going to get 2 moles here, and that's 1 mole. That means if you increase the pressure, more of this will react. So pushing the reaction to the right, forming more of those. So this is brown. More of this is being formed at equilibrium. You're going to see a lighter shade of brown. So you see that colorless mix with brown. Question 9.5. Hydrogen iodide gas decomposes into hydrogen gas and iodine gas at higher temperatures. The equation for the reaction is given here. Explain the effect of increasing the pressure on the equilibrium position of this reaction. Well, because they have same number of moles, 2 here on the left hand side and 1 there and 1 there. If you add them up, the stoichiometric mole on this side is 2 and the stoichiometric mole on that side is 2. That is the stoichiometric mole. That is the stoichiometric mole. 1, 1. And here is the stoichiometric mole 2. Because they're the same, increasing the pressure will have no effect. So no effect on equilibrium position due to there are equal number of gas moles or molecules of each side of the equation. Question 9.6 suggests the effect of adding a catalyst on the equilibrium position of this reaction. Well, a catalyst would not have any effect on equilibrium. So no effect on equilibrium position because catalysts only speed up a reaction to its equilibrium. Question 9.7. Copper forms colored compounds. Hydrochloric acid is added to an aqueous solution of copper compound A. The word equation for the reaction is copper compound A, which is blue, plus hydrochloric acid in equilibrium with copper compound B, which is yellow, plus water. The reaction mixture is green when both copper compounds are present in a solution at equilibrium. How can the equilibrium position be shifted to make the reaction mixture more yellow? Tick one box. If you want to make this more yellow, you want to add more hydrochloric acid to it, hence to push the reaction forward. So if we increase hydrochloric acid, then the reaction will go forward, more yellow will be created. So we need to add more hydrochloric acid. Question 9.8. The concentrations of the substances in this reaction do not change at dynamic equilibrium. Explain why. Well, the forward and reverse reactions are taking place at exactly the same rate.